scalar and vector projection.
Okay, class, today we're looking at projection under vector algebra and under vector algebra. And the projection we're looking at, there are in two forms. We look at one, the scalar projection. We look at scalar projection. And two, you look at the vector projection. We look at the vector projection. So we look at both the scalar projection and we look at what? The vector projection. Now, anytime you see a projection, you project onto something. So you project from something onto something. So a projection simply means, or a scalar projection is you project from maybe a vector B onto a certain vector A. So the projection is simple from one vector onto another vector. But with scalar projection, when you project from a vector onto another vector, it is the same of the component of the vector. It is the same of the component of the vector onto the other vector. That is for scalar projection. That is for scalar projection. So now with scalar projection, it is simple. The component projection or the scalar projection of B onto A, that is equal to the dot product of the two vertices divided by the magnitude of the vector on which it is projected onto. The magnitude of the vector on which it is projected onto. The same way, when you say a vector projection simple is what? A projection from one vector B, and let's say onto a vector A. A projection from one vector B onto a vector A. And now, vector projection of B onto A is a scalar projection times the vector in the direction of A times the vector in the direction of A times the unit vector in the direction of A. So anytime you want to find a vector projection, when you find the scalar projection and you multiply it by the unit direction, the unit vector of the direction of what? The vector on which it is projected onto, you find the vector projection. Alright, so now the vector projection is simply what? It's a scalar projection in short. It is a scalar projection. So vector projection of B onto A is a scalar projection of what? B onto A multiplying the unit vector of A. Multiplying the unit vector of the vector A. Multiplying the unit vector of vector A. So now what is the scalar projection? The scalar projection is what? A times B times the magnitude of what? The A. Multiplying the unit vector of A is what? A divided by the magnitude of what? Of A. So now when you do this, you simply got A dot B divided by, so magnitude you do what? Be the same as what? Your magnitude of what? Your A squared times the A times the A. So it's simply what? Your vector A squared sorry, this is a dot product, so you can't just do that. Times your vector A times your vector A. Alright, so this is how we do. So we just said a projection of B onto A. A projection of B onto A. So that's right. And for scalar projection, we write the component of B onto A is equal to A dot B divided by A. Alright, let's look at just two questions. One question, we find the scalar in the vector projection. Now, we have a vector B, 1, 1, 2. And we have a vector A, -2, 3, 1. So we have these two vectors. And on this side, we are supposed to find the scalar projection. On this side, we are finding the scalar projection of this particular vector. So the scalar projection of this particular vector says that the form of scalar projection of what? B onto A. Not A onto B. You are finding the scalar projection of B onto A. So that is your form of what? Onto B is equal to the formula over here. A in the dot product to B divided by the magnitude of the direction. The magnitude of what? A. So now how do we find? We have to know the magnitude of A. Alright, so knowing the magnitude of vector A, it is what? The square root of negative 2 all squared plus 3 squared plus 1 squared. And when you do this, you get the root of what? 14. When you do that, you get the root of what? Of 14. You get the root of 14. Alright, so now the scalar projection of A onto B. When you do the dot product of AB, you need the dot product of AB too. So therefore, dot product of AB is equal to 1 times negative 2 plus 1 times 3 plus 2 times 1. And when you solve this, you are getting what? 3. So therefore, your comp of B onto A will be equal to what? 3 divided by what? Your root of what? 14. 3 divided by what? Your root of 14. Now, the B part, it says you should find the vector projection. Find the vector projection. Find the vector projection of B onto A. The B part says you find the vector projection of B onto A. So now, you go write our formula. Projection of B onto A is equal to what? A dot B divided by the magnitude of A squared times A. Divided by the magnitude of A squared times what? Times the A. So now what do we do? Or it is simply what? A dot B divided by magnitude of A all times what? Magnitude of A. So we find the unit vector, the magnitude, and we do this. Now, what was the magnitude of A? The magnitude of A was what? Root of what? 14. The magnitude of A was what? The root of 14. So now, I already know this part, which is the scalar projection. So now we get what? 3 divided by root of 14 all squared. Root of 14 all squared. So root of 14 times root of 14 will be what? Root of 14 all squared, multiplying the vector A. And the vector A is what? Negative 2, 3, and 1. So root of 14 all squared, square here, take this away. So finally, for the vector projection, we'll be getting 3 on 14 divided by times the vector itself, which is minus 2, 3, and 1. And this becomes the end of the solution to the question. So that is the vector projection of B onto A, and that is the scalar projection of B onto A. So let's move on to the next topic.